In this lecture, we are going to see about what is threads. So as I told you, a program under execution is called a process, and thread is a basic unit of execution. So each program may have a number of processes associated with it, and each process can have a number of threads executing in it. So thread is a basic unit of execution or a basic unit of CPU utilization. So that is how we can define a thread. It is a basic unit of CPU utilization. Now let us see what comprises of a thread. So a thread comprises of a thread ID, a program counter, a register set, and a stack. So each thread comprises of these 4 unique items, and apart from this, it shares with other threads belonging to the same process its code section, data section, and other operating system resources such as open files and signals. So these are the things that comprises of a thread, and apart from that, the thread shares these things like the code section, data section, and other operating system resources are shared between threads belonging to the same process. So as I told you, a process can contain different threads. So the threads belonging to the same process will share the resources like open files, signals, code section, data section, and other things. So that is how a thread is basically made up of. So a traditional or heavyweight process has a single thread of control, but if a process has multiple threads of control, it can perform more than one task at a time. So a traditional process, also known as heavyweight process, had only a single thread of control. That means it can have only one thread, but this is not a very efficient system. But if a process is having more than one thread, then each thread will be assigned a different task, and hence that process can perform more than one task at a time because it is having multiple threads will be performing multiple actions. So that we see how threads becomes useful and how using threads make the system much more efficient. So let us understand what the concepts of threads using these 2 diagrams. So here in the first diagram, it is a single threaded process which we refer to as traditional or a heavyweight process over here. So here we are having only a single thread. So this whole block is considered as a process, and this process contains only one thread, and this is the code section, the data section, the files, the registers, and the stack belonging to this process. So there is only one thread. That means this process can perform only one task at a time. But in contrast to this, here we have another diagram showing a multi-thread process. So here this whole block represents a multi-threaded process. So it is a single process and it is having multiple threads over here. So if you see here, there are 3 threads in this process, and each of these threads, they have their own stack and registers. So all these 3 threads, they have their own stack and registers. And if you see on top, the code section, the data section, and the files belonging to this process are shared by these 3 threads, and each process thread, they have their own stacks and registers. So this is a diagram of a multi-threaded process. So in this case, this process can perform multiple tasks at a time because each thread will be performing a different task, and hence multiple tasks can be performed at a time by the help of this multi-threaded process. So from that itself, we must have understood that it is more efficient as compared to the single threaded process, and it will be make our computation faster and more efficient. So in most of the systems that we use today, we follow the system of multi-threaded process. It would be good if we can visually see how it works in our system in order to understand how processes are there and how threads are associated with the process.